We're working on 9.7, which is factoring special cases. You'll be able to factor perfect square trinomials and factor the difference of squares. So in the past 2 days, we have been working with trinomials in the form ax squared plus bx plus c. We've taken a trinomial and then been able to factor it out into two parentheses, and then we have been able to FOIL, first, outer, inner, last, together to check and make sure we get back to here. Today we're looking at special cases where we can kind of take a shortcut and know which factor that is created by the trinomial. When you are given something, which we have already talked about in previous sections, in the form ax or a squared plus 2ab plus b squared, we know this is what the factor looks like, and this is how we can write it. Just put in this squared because there's two of them. We also know that when I have a squared minus 2ab plus b squared, it is the same as these two factors, which is this. We're kind of reversing the order. So previously I had showed you this. You guys knew to put it into here. Now you're going to be given a setup like this, and I want you to be able to identify and just see, oh, that's in the form of that is a perfect square. So the shortcut, instead of taking a longer time trying to find that FOIL, which you guys know from yesterday's lessons that it does take a long time to do these, that this is what they're going to end up being. So let's take a look here. I got this straight from the book on page 529 of your textbook, and it says that you can factor a perfect square trinomial using the method shown in previous lessons, which is what we just talked about. Or you can recognize a perfect square trinomial and then factor it quickly. Yay, quickly, that's what we're looking for. So how do we do that? We need to look at the first and last terms and see if they can be written as the product of two identical factors. That is where the product of two identical factors is this. The product of two identical. So notice this parenthesis is the same as this parenthesis. This parenthesis is the same as this parenthesis. That's the product of two identical factors. Now the middle term is twice the product of one factor from the first term and one factor from the last term. Woo! It gets to be like a lot there. Okay? That's very wordy. Don't be afraid to stop, reread that. Now, what is that truly saying? This 4x squared. Let's start with this first bullet point, looking at the first and last terms. So 4x squared can also be written as 2x times 2x. So that's 1. And then the last term, 9, can also be written as 3 times 3. Notice that these are identical, which is what we're looking for, something that we can square. Okay, so really this is going to be the same as 2x squared, which is that a term. Here it's going to be the same as 3 squared, which is my last term, that b term. Now the middle term is twice the product of one factor from the first term and one factor from the last term. So twice the product, we know that's 2 times 1 from the first, there, you can see that in pink, and 1 from the last one, which is 3. 2x times 3 is 6x. 2 times 6x is 12x. So we know here that this is a perfect trinomial, square trinomial, because we can write this in the factored form and get this. When we FOIL that back out, we're going to get what I started with, 4x squared plus 12x plus 9. 9, this is a different example on this side here. Break 4x squared into 2, identical. 2x times 2x, just like before. 9, 3, and 3. That's perfect. However, when I take one term from the first, one term from the second to find that middle term, 2 times this does not give me that 20x, is not equal to, so this is not a perfect square trinomial. So because it's not a perfect square trinomial, you'll have to do what we did in the last section of finding by factoring things out in that trial and error piece of foiling. It just says it may help to write the first and last terms of these out. So kind of using the steps is going to be beneficial. Alright, let's take a look at an example here. We have m squared minus 6m plus 9. First thing we're going to do here is we are going to break up my first term. Took m squared, broke it up into m times m, and 9 to 3 times 3. Very similar to the problem we just did. Now, that's starting with the first and the last terms in my FOIL piece. Now we need to look at that middle piece. We know it's 2, 1 from my first, and 1 from the second. Well, 2 times m times 3 is going to give me 6m. So 2 times, which is the same thing here, is going to give me 6m plus 9. And this is m squared, which is what I was trying for. But now, how do I write this? So now that, yes, perfect, this does work. We need to be able to write it into, we haven't talked about that yet. Pull one term, your first term, minus second term, your 3, and then just square it. So this is how you rewrite this as a square. This next example tells you the area of a square is going to be 16h squared plus 40h plus 25 inches squared. Now we need to find the length. What do we know about the area of a square? Well, we know its length times the width, or base times the height. So 16. How can I break 16 up? Well, we know 4 times 4 is 16, and 25 is 5 times 5. So we can write it as 4h squared and 5 squared. Now this middle term, we take one of each and combine it. So you can see here, we took 2 times 1 of the first times 1 of the second to get 2 times 4h times 5. Now, 2 times 4h times 5 is going to be 8h times 5. 8 times 5 is 40, so it does check. This is 40. So we know my new one that we're looking for, that 5 squared. So it's really this twice. You can FOIL this back out. So if I gave you 4h plus 5, first, outer, inner, last, you're going to get what you started with, which is what we were looking for. So we just did an example where 1 was my first term here, and then we've also done them now when a is no longer 1, and it was 16, so we had to have something out here in front. To answer the question, the side is 4h plus 5, the length is 4h plus 5, and now we are going to talk about, in this next part, the difference of two squares. So now if I have a squared minus b squared, I know that I can rewrite it as this. So once again, we've started here and have worked this way. So now we're reversing that. I'm going to give you a trinomial. Actually, it's just a bi, because there's only 2, but a squared minus b squared. And you should be able to kick out that this is the factor for that. So they've showed you some examples here that you can look at. We are going to go and do some minus 6. So the difference of these two, because it's subtraction, we know I can break this first term and the second term up into squares. So this is already done for you. Now this second one, how can I break 16 up into a perfect square? Well, 4 times 4 is 16. So now I know my b term there is 4. I can write this as a plus 4 and a minus 4. Then check it with FOIL. First, outer, inner, last. Simplify, these are going to cancel out and just leave me with a squared minus 16, which is what we started with. So once again, you're breaking up a squared minus 16 into a squared minus 4 squared, and then just using these terms and changing the sign of your factor. Another one, now your a is no longer equal to 1, so we need to break 9 here up. Well, 3 squared is 9, so I can do 3b squared. And 225, we did not know that that was 15 squared. You could always take the square root of this to find that answer. Because it's subtraction of two perfect here squares, we know we can write it as 3b plus 15 and 3b minus 15. You will FOIL to check it. Oops. Once you FOIL and check it, you will find that you do get your original, and so that it does work, that these two are the factors of your original. This last example here is just another one where you can pull something out to start. So 5 is a factor of 80, so I can pull out a 5 and get x squared minus 16. This should be able to kind of like ring that. You will eventually be able to see quicker that that is another one that we can factor out. I pull out a 5. If you have trouble with this, just check it once you're done and distribute the 5 back in. 5x squared, 5 times 16, and you're going to get what you started with, so you know you did it right. So now I have 5x squared, break that up, where I know it's going to be x and 4, because x squared minus 4 squared, and we're going to use the minus and the plus here. So you can see, as they kick it through, x plus 4, x minus 4, and we can check it using FOIL. So the first ones you're going to do is first, outer, inner, and last, and then times it, then distribute your 5, and this is what you started with. So you know this is the factors of what we started with.